In this video, we're going to talk about special right triangles. We are going to use trig definitions and special right triangles to derive trig ratios for 45-degree angles. And then we are also going to solve problems, including special right triangles, by using those trig ratios that we've come up with. So when we have a 45-45 triangle, we know that the length of the hypotenuse equals the product of square root of 2 and the length of the leg. So this is from last semester. We know this already, that if we have a 45-45, 90 triangle, we know that the side lengths are A, and square root of 2 times A. So whatever these two sides are, they're the same, right? Because they're the opposites of the 45-degree angle. They're the same. And then this one is just square root of 2 times whatever this number is. So we have determined that, that the side lengths in a 45-45 triangle are S for the lengths of the legs, and then the hypotenuse is S square root of 2. So we're going to use these relationships to find the values of the sine and cosine and tangent of a 45-degree angle. So if you notice here, what we did is we said sine 45, right? Remember SOHCAHTOA. Okay, that's a big, oh, let me change my pen color. Okay. There we go. Okay, SOHCAHTOA. Sine is opposite over hypotenuse. Okay, so here in a 45 triangle, all right, if we have 45, we have opposite is S, and then the hypotenuse is S square root of 2. All right, so what we want to do is rationalize the denominator, right? We want to get rid of this square root of 2 on the bottom. So what we did was we multiplied both sides by square root of 2. All right, so then when we multiply that, we get square root of 2 times square root of 2 is square root of 4. So we have S square root of 4, and then we have S square root of 2. So now these S's here canceled out. Square root of 4 is 2, and then you have square root of 2 left. So we know that sine 45 is going to equal square root of 2 over 2. For cosine, okay, if we look here, cosine is adjacent over hypotenuse. All right, so if we do 45 here, look, we have the same exact thing, right? Because cosine is S over hypotenuse, which is S square root of 2. So actually sine 45 and cosine 45 are going to give us the same identities. They're both going to give us square root of 2 because they're the same numbers. They're the same ratios. Tangent 45, okay, so we have opposite over adjacent, okay. Opposite is S, and then adjacent is S. S over S, anything over itself is going to be 1. So tangent 45 is always going to be 1. Okay, so here's just a recap. If the measure of the angle is 45, the sine and the cosine both equal square root of 2 over 2, and tangent is going to equal 1. Okay, so here's just a little recap before we do some problem solving using those trig ratios. Here it says, if the square has side lengths with S, how long is the diagonal? Okay, so here we have S. Okay, we know that a square has all the same sides. All right, so if this is a 90-degree angle, then we can solve this. We can use Pythagorean theorem to find this side right here, right? We have a squared plus b squared equals c squared. So if we plug this in here, right, we have s squared plus s squared equals c squared. So now we can add these two together, right? If we have add these two together, and s squared plus s squared is 2s squared. All right, now if we look over here, c squared, okay, c is this line right here. That's going to be ac. So we'll just plug in ac for that, because that's what we're wanting to find, is what ac equals. So now, okay, we have ac squared, so we're going to take the square root of both of those. Okay, so we get that ac equals, and here s squared, right, we can take an s out because s times s is s squared. So that gives us s square root of 2. So we know that this line right here is s square root of 2, which we already knew that, right? We're just proving this, that this is s and s square root of 2. So what that tells us then, here it says, what are the measures of the 4 acute angles that the diagonals makes with the vertices? So for example, angle BAC. So it's wanting to know what are the measures of these angles right here, these small angles. Well, since we know that in a triangle, right, we have an isosceles triangle here because we have 2 equal sides, and this side length is s square root of 2. We know that this is a 45, 45, 90 triangle. So we know now that this angle BAC is going to be 45 degrees. We know that all of these are going to be 45 degrees. So if you have a square and you have the diagonal, then you know that the angles are 45 degrees, and you know that the diagonal equals s square root of 2. This says approximately how long is the leg of an isosceles right triangle that has a hypotenuse length of 14.14 centimeters. Okay, so let's draw a picture here. So we have the hypotenuse, 14.14, and then we have these two x's because we don't know. So we just want to know what is the length of one of the legs. All right, we know that this is a isosceles right triangle. Okay, isosceles right meaning it has the 90-degree. Isosceles meaning the other two angles are the same. So that automatically is telling us that this is a 45-45 triangle. So the way we can use those trig ratios that we learned earlier, right? We learned that sine 45 equals square root of 2. Okay, so there's several ways you can do this. Because if we wanted to, remember SOHCAHTOA, okay? Just want to beat that in, right? SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So here if we have sine, opposite is x, hypotenuse is 14.14. So we have sine 45 equals the opposite, so that's x, over 14.14. Okay? Now, if you have your calculator, right, your graphing calculator, you could just do sine 45, right, and find out what that is decimal wise. Okay, but if this is one of those ways that if you don't have your calculator, we already know that sine 45 equals square root of 2 over 2. So we can sub in square root of 2 over 2 in for sine 45. And then we are left with x over 14.14. So now all we have to do is cross multiply. So we would take 2 times x, which is 2x, and then we're going to take 14.14, and we're going to multiply it times square root of 2. Now, for the purposes of this, we are going to say that square root of 2 is going to equal, we're not going to use the whole number. We're going to say 1.4142. All right, so we're going to take 14.14, and we're going to multiply it times 1.4142. And that gives us 19.996788. So that's pretty close to 20. So we're just going to round up to 20. So then we divide by 2, and x is going to equal 10. Okay, so we know that these side lengths are 10 right here. This says if a ball is thrown from first base to second base, and then from second base to home plate, how many feet has the ball been thrown? Okay, well, if we look here, all right, we know already that this is a square, right? It's a baseball diamond. It has a 90-degree angle right here. So we automatically know with this diagonal here that cuts the square in half, we know that this is a 45, 45, 90 triangle. We know that from first base to second base is 90. Okay, so the first thing, before we can add and figure out how many total feet the baseball has been thrown, we need to find the length of the hypotenuse. Okay, so again, remember our, SOHCAHTOA. All right, so here, okay, if we take the sine of 45, Okay, sine 45 is opposite, so that's 90, over the hypotenuse, which is x. All right, that's what we want to figure out. We want to figure out what is x. All right, so again, remember, we know that sine 45 is square root of 2 over 2. Okay, so we have square root of 2 equals 90 over x. Now we're going to cross multiply. So we have square root of 2 times x equals 180. And then we're going to divide by square root of 2. Okay, now remember, we are using 1.4142 for square root of 2. So we're going to take 180 and we're going to divide that by 1.4142. And that's going to give us that x equals 127.3. So we know that the length of the hypotenuse is 127.3. So now if we take that 127.3 and we add it to 90, it's going to give us that the baseball was thrown 217.3 feet total. Okay, and this is just another reminder when we are using sine and cosine, if you are using your calculator, make sure when you press mode and then you go and press the degree so that it's in degree mode. And that is the end of sine and cosine, or sorry, special right triangles part 1.